So, I recently decided to sell my vacuum cleaner. All it was doing was gathering dust. Okay, fact. An average home collects about 40 pounds of dust per year. No, wait, that's not funny. It's as heavy as 2 dachshunds or 4 cats. Alright, that's enough. One of the most popular household dust myths is that it's mostly made up of your own skin cells. Hey, you remember the song All We Are Is Dust in the Wind? Yeah, it's a sad tune. But in reality, dust has a way more complicated structure. You bring 2/3 of all the dust in your home from the outside. It's in the dirt, the soil, and the mold that sticks to your feet. It's in the pollen, spores, human-made pollutants, and other airborne particles that hang onto your clothes, hair, skin, and shopping bags. So, this means you're kind of filthy, huh? Even if you never left the house, you'd open windows to get some fresh air. This is when even more dust comes in. If there are trees right by your window, you get in some extra dust from birds' feathers and mites. The remaining third of all of your house dust comes from carpet fluff, clothes fibers, your pets, and even your food. Bits of fiber and crumbs of food from your lunch contribute to dust composition. So do your carpets, rugs, drapes, curtains, towels, and upholstered furniture. Your clothing sheds fibers that transform into dust. If you're using fabric softener, you're making things even worse. It coats the fabrics with a nice smell and extra softness, and that coating flakes off in more dust. If your pets go outside, they also come back with a souvenir of pollen and mold spores on their fur. When they're inside, they leave dried saliva in different parts of the house. When they groom, it gets on their fur and then falls off and transforms into dust. It's mostly clingy in cats, so if you have a cat owner visit your petless house, you could get that new source of dust as well. Plus, dried saliva is the worst of pet allergen sources. And yes, you are also a source of dust. The percentage you add to the mix is tiny, but still. You shed a lot of skin all day, every day. It renews every 4 to 5 weeks. All the dead skin that comes off in 1 week weighs about as much as a car key. Most of all those flakes fortunately end up down the drain when you take a shower. Some of them stay on your mattress and pillow, and on furniture and carpets. When you contact any of these surfaces, the skin flakes take off on their exciting journey around the room. They travel until they settle on a new surface or come back to where they came from. Your hair also takes part in dust production. When you shed it, little hairs break into even smaller particles and end up in dust. It's not just the hair off your head, but also brow hairs and eyelashes. If you're a fan of hair and skin products, like gels and sprays, they also contribute to dust production when they flake off in tiny particles. Even the nail polish that chips becomes dust. All that shed skin becomes food for dust mites. They're colorless, tiny creatures, less than 1/10 the size of an ant. They have 8 legs and no eyes, but a fantastic sense of smell to find food and good places to lay eggs. They eat animal skin, pet dander, and some fungi. Their favorite place to eat out is your bed. It's warm and dark and a bit damp, just what they need to breed. The more they eat, the faster they grow. When they grow, they get a shell over their body that becomes house dust when they molt. When a dust mite life cycle is over, its body also becomes dust. The only way to stop dust mites for good is to cover your bed with a dust mite-proof mattress cover and wash the linen in hot water every week or freeze it. But that would just help you get rid of one source of dust. Even if you clean and vacuum the entire house every day and control your pets' every move, it would still stay in your house. You and your pets could have allergies, a runny nose, itchy skin, dry eyes, cough, and sneeze. Dust can also have solid particles or liquid droplets in it that are tiny enough to get inside your lungs or even the bloodstream. That could give you more serious health issues than an allergy. Normally, it happens to industrial dust, such as that from diesel engines. A room packed with electronics always has more dust in it. The amount keeps growing. It ruins the cables and jams the expansion slots. The gadgets are overheating, the contact becomes worse and worse, and the repairs cost more and more. Don't forget there's also outside dust. It comes from similar sources: soil particles, pollen, tire particles, insects, and the like. Dust isn't the same around the world. The composition of dust can be as unique as your fingerprint. It can have quartz, coal, or volcanic ash from the air in its composition at different percentages. If you live in coastal or desert areas, there's more dust from the sand and winds. Dust seems so useless, so why don't we just put up a dust mite-proof cover on the whole planet, or freeze it, or find some other way to get rid of it altogether? Let's suppose it did happen. All the dust in the world is gone. You go out to your backyard to celebrate and watch the sunset. There's not a cloud in the sky, so it has to be a good one. Yet, there's no usual sky show of pink, orange, and purple. The colors seem faded. That's because the dust in the atmosphere contributes to gorgeous sunsets and sunrises. When the sun is near the horizon, its beams reflect off the dust particles in the atmosphere. The dust eats up blue and green shades, but allows the orange and red colors through. Without it, the colors are way less intense. So you turn on the TV and hear reports of changes in weather patterns. The Sahara Desert used to be the largest source of dust in the world before it was gone. It used to deliver hundreds of millions of tons of dust through the atmosphere. Dust went across the Atlantic Ocean to South America in such huge plumes they could even be seen from space. It carried valuable phosphorus, potassium, calcium, and iron to the tropical soils of the Amazon rainforest. All those elements are good for plants, so the Amazon would be less vibrant without dust. Saharan dust also brought iron to the ocean. It helped marine algae bloom and made the ocean more productive. Dust and its absence affect ground cooling, air temperatures, and rainfall levels. When it gets in the air, dust traps heat below it, making the surface under it warmer. Water molecules form clouds around dust in the air. When the droplets are heavy enough, they fall to the ground in rain. So, without dust, there would be not that much of rainfall. Water vapor wouldn't be able to condense or freeze into fogs either. London and San Francisco would have to change their songs without fog. And there would likely be more hurricanes. The dusty layer works together with the dry air in mid-atmosphere to prevent them from forming. It saved many lives. Dust also takes part in keeping the radiative balance of our planet in order. It helps scatter and absorb solar radiation and changes optical properties of clouds. Mammals, including dogs, cats, horses, pigs, and birds, are going crazy. They used to take dust baths to keep their skin, fur, and feathers healthy and clean of parasites or dry up. Some mammals also use dust bathing to leave their pheromones and scent on the ground and mark their territory. Perhaps there would have been no life on Earth without dust altogether. Some studies claim that dust takes part in transfer of life between planets. Cosmic dust is made of carbon, oxygen, iron, and other atoms heavier than hydrogen and helium. It's the building material for planets and people. Stars wouldn't form without it either. Streams of cosmic dust are traveling fast into the Earth's atmosphere. In there, they bump into particles and give them enough energy to jump into space and probably even travel to other planets. It also works the other way. So, space dust collisions could carry life between planets. Suddenly, you don't feel that bad about dust after all. Except for that dusty table and that lamp and, well, never mind. Jupiter's gravity shattered a huge comet. It wasn't enough for the space monster. A real catastrophe happened. The shards didn't fly in different directions. They lined up and rushed towards Jupiter like the rail cars of a train. 21 fragments up to 1 mile in diameter burst through Jupiter's atmosphere. Fireballs at the speed of 37 miles per second bombarded the planet's shell. They heated the space around them to 50,000 degrees Fahrenheit. That's higher than the temperature in the sun's upper atmosphere and 312 times hotter than you need to boil an egg. Well, I'm not hungry anymore. The impact was like from a rock falling into a pond. The meteorite fragments formed giant plumes on the surface of Jupiter. Substances from its lower atmosphere rushed upwards. The process generated a tremendous amount of energy. Overheated streams of fire shot into the stratosphere. The monsters left behind them glowing plumes 1,900 miles long. That's greater than the distance between New York and Texas. Dark bruises appeared at the side of the blows. They were about the size of the Earth. Comet Shoemaker-Levy 9 was the name of the violator of Jupiter's boundaries. The collision of celestial bodies happened in July 1994. It was a scientific sensation. For the first time in human history, a catastrophe of this magnitude was observed. The attack raised an important question for astronomers. Why is Jupiter unlucky? Space monsters attack it thousands of times more often than the Earth or any other planet in the solar system. Alright, let's see. You decide to board a starship and travel to the mysterious Jupiter. A space probe would need 2 years to get there, but your starship is faster. You'll be there in… Great, the journey only took a second. Jupiter is actually big. It could fit 1,300 Earth-sized planets in it. It looks beautiful thanks to gas clouds. This planet has no solid surface, but there's a strange stain on its surface. It looks like a huge eye that can fit 3.5 Earths. This storm will scare anyone. It's 10 times higher than Everest, and the wind rushes at a speed of 300 miles per hour. It's been going on for 350 years. You wouldn't hide from such a storm in a car, so it's good you're in a starship. If all the planets of the solar system merged into one superplanet, the new object would still be 2.5 times smaller than Jupiter. Large size also affects gravity. Spacecraft use Jupiter as a springboard to jump. The giant's gravity increases their flight speed and helps them reach their target faster. Gravity has turned the planet into a magnet for comets, asteroids, and dangerous space debris. Jupiter is a true space superhero. Its gravity shield takes a hit and deflects space monsters that fly into the inner solar system. The dinosaurs don't agree, but more on that a little bit later. What if Jupiter was swallowed up by a giant vacuum cleaner tomorrow? I can only say one thing: we'd have huge problems. Without a giant shield, thousands of comets and asteroids are attacking the planet much more often. Most of them burn up in the atmosphere or aren't large enough to affect us. But there are also larger comets and asteroids. After their collision with the Earth, you can say goodbye to all life on the planet. For example, in 2009, a celestial body crashed into Jupiter. It left a bruise the size of the Pacific Ocean. It's scary to think what traces it would leave on our planet. Most likely, the Earth would turn into a fireball. But recent research from astronomers suggests that Jupiter isn't such a nice guy. On the contrary, it's a bad guy with a slingshot that shoots comets at the Earth. A physicist used computer simulations. He found that Jupiter is equally likely to deflect and send comets toward the Earth. The giant attracts potentially dangerous objects and only partially protects us. It's already tried to knock out our planet many times. 66 million years ago, a cosmic body 10 miles in size crashed into the Earth. The energy of the impact set the surface of the planet on fire. It caused a huge earthquake and tsunami. A fiery rain fell from the sky on the Earth. There were millions of tons of debris and dust in the atmosphere. They stopped the sun's rays from reaching the planet. The nuclear winter began. This disaster led to the extinction of the dinosaurs. Scientists have named this space criminal Chicxulub Impactor. Computer simulations of scientists at Harvard University showed where it came from. Chicxulub wasn't an asteroid, but a comet. This means that the core of its body wasn't stone and metal, but ice, dust, and frozen gas. It resembled a dirty snowball flying through space. The meteorite wasn't going to set fire to the Earth, but Jupiter intervened in the plan. It threw comets in our direction. In 1770, Lexell's comet appeared near the Earth. Our planet and this object were separated by only 1.4 million miles, close to nothing in space terms. Lexell's comet came closer to Earth than any other comet in human history. The object could have stopped life on Earth. The comet flew too close to Jupiter. The giant caught it and sent it in our direction. Now, this isn't a very good move for a superhero that protects the solar system. After 3 years, the comet went past us. It flew 2 times around the sun and returned to Jupiter like a boomerang. This time, the giant pushed the comet out of the solar system. But let's not blame Jupiter. Scientists believe that without this gas giant, life on Earth would most likely never have happened. Jupiter sent meteorites toward Earth, which carried organic molecules and water with them. They were the building blocks from which earthly life began. Nobody knows if comets would come with a valuable cargo without Jupiter and its dangerous gravity. If you fly away from Earth to the center of the solar system, you'll see the sun. 8 planets are flying around this star. There's a belt of more than 1 million asteroids between Mars and Jupiter. One theory says there was only the Sun at the very beginning of the solar system's existence. Clouds of stone and dust surrounded the star. These particles attracted each other and formed planets over millions of years. Jupiter didn't want any new neighbors. Its powerful gravity prevented rocks and dust from uniting into planets. They remained asteroids and gathered in a belt inside the solar system. If today all the asteroids merged into one planet, we'd get a cosmic body that would weigh only 4% of the mass of the Moon. Previously, the belt was densely populated, but Jupiter's gravity threw 99% of the asteroids to other places in space. Jupiter isn't the only one that plays a role in the development of life on Earth. Our main assistant is the Moon. It's the only natural satellite of the Earth. Jupiter has 79 satellites, and every year there are more and more of them. Jupiter is also surrounded by rings, but they aren't as beautiful as Saturn's and are practically invisible. The rings are composed of small black particles. This is the dust that the meteorites eject into space after colliding with the moons of Jupiter. The Moon is responsible for the ebb and flow of the ocean. It regulates the life of bees, fish, birds, and amphibians. Even you feel the influence of the Moon every day. Changing the brightness of the disk in the night sky regulates the level of melatonin in your brain. This hormone is responsible for circadian rhythms, which are important for healthy sleep. The Moon came about thanks to another catastrophe, like many other things in space. Millions of years ago, the Earth looked like a ball of hot lava. There was no water or air. It was enveloped only in carbon dioxide and nitrogen. At this time, another planet the size of modern Mars crashed into the Earth. Scientists named it Theia. At a speed of 8,900 miles per hour, it collided with the Earth. The impact of incredible force threw millions of tons of material into space. The debris gathered into a ball that became known as the Moon. Scientists have almost solved the mystery of the Moon, but they don't know if there's a solid core in the middle of Jupiter or if it's dense hot soup that hangs in space. Jupiter has the largest ocean in the solar system. It's made of liquid hydrogen, not water. If Jupiter were 80 times more massive, it would turn into a bright star. Jupiter is a unique place that will never be home to humans. The pressure inside the planet is 2 million times greater than on the surface of the Earth. Extreme pressure and temperature would ruin any spacecraft that's gone too far. I guess that means Jupiter would have a crush on you.
How much would a pinch of sand be worth to you? How about without the elements of gold or platinum mixed into it, just moon dust? A recent auction sold it for $500,000 for literally just a pinch of what's on the Moon. But this apparently valuable minuscule amount of dirt was valued purely on its historical relevance. That pinch of sticky moon sand was from a small pouch that was collected by Neil Armstrong on the Apollo 11 mission in 1969. It was a huge piece of human history and a physical reminder of when man first landed on the Moon. Something taken from a place that no one else has ever been able to. Selling something from the Moon opens a whole new debate around the legality of owning, using, and selling space resources from unclaimed parts of the solar system. Currently, the world abides by the 1967 Outer Space Treaty, which depicts the foundations of modern space law. This treaty, established so long ago, didn't predict the lucrative use of outer worlds for resource utilization. Although this treaty prevents anyone from claiming ownership of any new worlds, the potential value of these unclaimed territories is priceless. The Moon is not only a stepping stone for future exploration into outer space, from which moon bases and possibly moon cities will one day thrive. For this purpose, humans will need to develop shipping bays and factories to support carriers to cross into new worlds. This project will need some good investments. Mining stations will provide the economy of the hypothetical moon city. There will be infrastructure and transportation to the Moon and back again. All of this will cost a lot, way more than a reminder of when man first walked on the Moon. So, apart from moon dust, what else could be valuable on the Moon? There is value in the resources on the Moon. We don't know the exact numbers, but it's estimated that there is more than was thought in the past. The Earth's natural satellite is believed to be abundant with iron, nickel, and cobalt, amongst many more. These minerals provide the potential for building Moon City itself. Just as in human history, cities around the world are a reflection of what resources are in abundance in their surroundings, and Moon City will be the same in that way. A gray city, walls made with metal, iron dust, and a lunar sand concrete, with great windows made from the unlimited sand available. The moon is also rich in silicon, an important ingredient in producing solar panel arrays. There's calcium to be used to fabricate the silicon-based solar cells, along with other ingredients found there, like titanium oxide, iron, and aluminum. The long-dormant lunar magma ocean residing under its surface holds magnesium. It's especially prominent within the lower crust and is useful for many purposes, most importantly for alloys with expected space travel. The production of steel requires many sources of carbon, crucially important for supporting the mega factories and for the many thousands of ships that will be built. Numerous rare earth materials are used in everything electrical. They continue to be more valuable, and their production is more prominent as technology progresses, especially in electric vehicles and wind turbines. Although rare earth materials are abundant on our planet, you won't find them in many concentrated areas. They are spread thin throughout the Earth, so locating and mining them is pretty costly, though they're more required with every year. The process of finding and mining on the moon is far easier and will be an important alternate source. Nitrogen, along with carbon, are important elements to support human colonization and farming, and ensure that the moon is not only habitable, but has a constant supply of food. We can obtain them within the moon's outer crust, so farming is possible there within sealed biospheres. Mining metals is a difficult process, but the result is worth it, not only for their value, but also because of the valuable byproducts that you can get in the process of extraction. It can be oxygen, available for breathable air within the city, and hydrogen to ensure water for the plants and for drinking. Valuable resources will not only come from within the surface of the moon. Its potential for solar power is so huge, it will ensure harvesting the solar waves to power Moon City. The fact that it lacks a thick atmosphere and that there's no interruption of weather patterns removes some major obstacles that are present on Earth. The energy created could be sufficient for all requirements on the moon, and, in the short term, may also help solve many of Earth's power concerns. Extracting resources and manufacturing requirements will be significant as time carries forward. As Moon City is going to grow, and humans will reach further into outer space, it will require more and more energy. The output to factories and production on the moon will become so elaborate that they will need alternate sources in reserve. Atom-powered fusion will be an important source of energy with no dangerous byproduct. It will be safer than the technologies of today that use uranium. Feeding this kind of fusion will require the most valuable of all resources found on the moon, helium-3. It's not only present on the moon, but can also be found on Earth. But the amount is super limited here due to our planet's strong magnetic field. It ensures life can thrive on Earth, but at the same time deflects the solar winds from the sun, making it difficult for helium-3 to be produced. The moon has no magnetic field and has been absorbing the solar wind for billions of years, constantly building up an endless supply of helium-3 in the process. It absorbs the winds into the top layer of solid material on the moon, also known as the regolith. The regolith is spread all over the moon, and it makes the extraction of the helium-3 an even more valuable action. Mining it would also include mining all the other valuable minerals in the process. The value of helium-3 is so substantial that many countries and companies are determined to gain a foothold on the moon. The value of this alone is within trillions of dollars. Some people believe the opportunities that helium-3 will give humanity are immeasurable. There will be unlimited energy providing millions of jobs in Moon City. That energy will also support the Earth's needs. Only 25 tons of helium-3 could power the United States for an entire year. This resource will provide the potential to power all of Earth for thousands of years and have enough energy required to help guide humans further into space. It will enable the construction of spaceports around Earth and allow for a more efficient journey from Earth to orbit. From there, people will be transferred to shuttles destined for other locations throughout the solar system. The lengths of spaceflight will be reduced significantly, creating more frequent flights toward Mars. Further ports will be erected around its orbit, supporting new colonies to reside on its surface. Mining colonies with the support of endless energy will spread throughout the red planet, with more valuable resources residing within its red soil. This new age of colonization in the solar system will cause a domino effect as it continues to push further, advancing with every generation of vessels developed. Travel will get more and more efficient as the helium-3 will continue to assist in advancing the technology of spacefaring ships. Outposts of all purposes will develop on the moons of Jupiter and Saturn, from researching for potential habitability for life on Europa or Enceladus, to continuing the tradition of extracting valuable resources in every location. The moon will continue to find ways to provide the energy that's needed for terraforming new worlds. It will assist in warming Mars and powering an artificial magnetic field. It will also help with constructing a large reflector that will be able to cool down Venus. All of these will be the foundations for creating further livable locations for future generations of humans, all thanks to that initial source of energy from the moon. It's difficult to put an overall price tag on the moon, even when you know that there is value in harvesting its resources. The value of what the moon dust really amounts to can't be determined by a monetary figure, but by its potential to influence what humans can create as we continue to progress as a species.